right, we got a couple more. What's different about this next one? Yeah, our calculators are set in degrees. We can reset them if we want, but then we have to remember to set it back, and sometimes we forget. So it might just be easier, like Olivia said, just to change this into degrees. So pi is 180, divided by 10 is 18, times 3 is 54. Now, what are we doing? We're changing into complex or rectangular form. So that means we want x and y. So Taylor, what's x? Always, always, always x equals?
The x r cosine.
Yes. X equals r cosine theta, and y equals r sine theta. So for cosine 54, Jordan, what do you think about that? You okay?
Yeah, I'm good.
You sure?
Yeah, I'm fine.
Okay. So if I ask you to help me with the next one, which is written longhand, so I'm going to write it. Are you even on the right page?
I'm on the right page.
So now I'm shorthand, shortcut here, short version.
Yeah.
How would we do this? We want to transfer that into x plus yi. So how do I find my x and my y?
Your x would be 6. Well, 6 cosine 200. It might be 6 sine 200.
Perfect. Don't be so hesitant. That's exactly right. So 6 cosine 200 there's your answer. Everybody good? Now we got a couple of really easy things, but I got to tell you the rules. Very, very simple. Very simple. If we have two numbers and we've given them names, so z sub 1, z sub 2, don't let that confuse you. Think of it as Joe and Bob. Those are just the names of the numbers to identify them, distinguish between them. We've given them names. Now we want to multiply them together. This is one of the coolest things ever. It can be proven using some identities that we don't know. But I'm going to write down the answer and you tell me what I did. It is so amazing. If I want to multiply these two numbers together, this would be the answer. I don't have to show any work. I can do it all in my head. It's super simple.
Multiply r's and add thetas.
Exactly. Multiply the r's. These are the r's. These are the thetas. Remember your number is RCIS theta. We multiply the r's. We add the thetas. That's all there is to it. So in the next one, where we are multiplying these two numbers, what would the answer be? This is problem 4B. 20 CIS 410. Are you in agreement with that? Now here's one of the picky little rules. tell me about 410. It's too big, isn't it? So when we write our final answer, this is correct. But when you write your final answer, you don't want to have an angle that's bigger than 360. So instead of writing 410, we're going to shrink that down to 50. And that is going to be the final answer. How did I shrink it down to 50? What did I do? Minus 360. 410 is more than a loop. So get rid of that extra part. If your answer ends up bigger than 360, shrink it down. That's easy. All right. I'm not even going to tell you how to do the next one. I want you to guess. I want you to think about how we did this.
Divide, subtract.
Exactly, Olivia. You spoiled the fun for everyone, but you are exactly right. Olivia said if I want to do this division, my answer will be 2 CIS 9. Divide the R's, subtract the angles. Max, how did I do the multiplication? I multiplied the R's and I added the angles. So in a division, I will divide the R's and subtract the angles. Okay, one more time. In a multiplication, I multiply the R's, add the angles. In a division, I divide the R's, subtract the angles. So what would this last one be?
6 fifths.
1.2.
So I divide, let's see, 18 over 15.
1.2.
1.2 or 6 fifths if I just leave it as a fraction. 1.2 is fine. 1.2, 6 fifths. And then what? Negative 100.
Use the
Remember how we couldn't have an angle bigger than 360? Well, you can't have an angle less than 0. So how am I going to create this? I'm going to add 360 to it. And this will be 260. Now, kids, don't be confused. How did you fix this problem? You subtracted 360, right? How are we going to fix this problem? We're going to add 360. If the number's too big, subtract 360. If the number's too small, add 360. Okay? Huh? It's always 360. Now, depending on the problem, you may have to add twice. So if you got a really like negative 1,000, then you would have to add 360s, keep adding 360 until it finally became positive. But it's always 360. Always 360. Okay? Now the moment we have been waiting for. Everything in this chapter is leading up to this moment. Here we go. We are going to do this problem. Now, you already know how to do the problem. You could FOIL this out. You could do 2 plus 2i times 2 plus 2i times 2 plus 2i times 2 plus 2i. It would take a while, but you could do that. The coolest thing about polar coordinates, however, are that you can do that snap of a finger. We can get the answer here pretty darn quick. The only problem is you got to be in polar form. So the first thing we're going to do is what we practiced earlier. We're going to change this into RCIS theta. So we're going to take this number and we're going to find R and we're going to find theta. Now we know how to do that. Bo and Blake and everybody else has said, draw a picture. Find R and theta. All right, so here we go. Can you tell what theta is? This is an easy one.
42.
That's a 45. See how those match? That means it's a 45. And since it's in quadrant 1, it's 45. We don't have to do anything to it. Now we need to find R. What's R going to be? 2 root 2? Or the square root of 8? I'm going to leave it as a square root of 8 and you'll see why. Oops, it goes there. You'll see why in a minute. It's 2 root 2. If you want to use 2 root 2, go ahead. Now, this is one of the coolest formulas ever. It's called de Moivre's theorem. And it says that if you want to raise a number in polar form to a power, all you have to do is raise the radius to the power. So this is your R. Take R to the power and multiply the angle times the power. So the actual theorem, if I wrote it out, says raise the radius to the power and multiply the angle times the power. Raise the radius to the power and multiply the angle times the power. So this means root 8 times root 8 times root 8 times root 8. What do these two make? What's root 8 times root 8? 8. And these make another 8. So that's 64. And then 45 times 4 is 180. There is your answer in polar form. Now the directions say answer in complex and polar. So this is the polar form. Complex form means x plus yi. So I need to find x and y. And how do we always find x? X equals r cosine theta. Y equals r sine theta. So typing it in on the calculator, we get negative 64 plus 0i. And that is our complex form. I am so excited by that, and I can tell you R2, we're going to do one more. Okay? What? No, you could write this as negative 64. All right, here we go, guys. This is amazing. This is absolutely amazing. I erased my problem, but here's what I want you to see that makes it so cool. The exponent was a 4. What if the exponent would have been a 10? Would there have been any more work involved if it would have been a 10?
No.
No. So you can raise things to big powers without doing all that foiling. Just like this. All right, let's try one more. -1 plus root 3i, and we're going to the 5th power. Look back at the last problem. What do I have to do first? Put it in the polar form. So first I need to find r and theta. So we'll draw a picture. What's my r this time? Come on, let's not freak out because there's a radical in there. We are grown-ups. What's root 3 squared? 3 plus 1, 4, square root, 2. If you're really with me this morning, Monday after spring break, you can look at that triangle and tell me how big that angle is without a calculator.
60 degrees.
That's a 60 degree. The theta's not 60. What's theta? 120. So this is 2 CIS 120. And that's what you are raising to the 5th power. So we took the number that we were given, we found the r for it, and we found the theta for it. Now we're going to do de Moivre. What does the theorem tell us to do? 2 to the 5th, and 120 times 5. So we take the radius to the power, and we multiply the angle times the power. So 2 to the 5th is 32. 120 times 5 is 600. Whoopsie, whoopsie, whoopsie.
That's too big.
What about 600?
Too big.
Too big. So 32 CIS, remember when they're too big, we subtract 360? So 240? What form is that? That's polar. So now to find the rectangular or the complex form, we'll take 32 cosine 240 and 32 sine 240. You with me on that? So 32 cosine 240, -16 minus 27.71 odd, and there's your complex form. Aren't you so glad that you started today with math class? Think of all